Drop a heavy stone in a quiet room, and your brain immediately processes a very simple story. You instinctively assume three things. First, the space between your hand and the floor is empty. Second, an invisible force pulled the rock down. And third, the physical world where this rock exists had a definitive beginning point in time. It feels perfectly logical. Yet modern physics has demonstrated that these assumptions fail to describe the actual state of the universe. These everyday phenomena are so deeply counterintuitive that for centuries, brilliant minds struggled to explain them. When Isaac Newton mapped the laws of motion, he couldn't grasp how objects influenced each other across millions of miles of empty void, ultimately concluding that this invisible influence had to be the literal hand of God. To understand the mechanics of reality, we have to strip away our human intuition. The physical architecture holding us together is stranger and far more complex than the myths we use to explain it. Let's start with the air around you. If you remove all the atoms, light, and heat from a room, you are left with a dark, silent void. Or so we thought. According to quantum field theory, the universe is actually composed of continuous, invisible fields. There is an electron field, a photon field, and a quark field, all overlapping and extending across the entire cosmos. And because of Heisenberg's uncertainty principle, these fields can never be perfectly still. Even in a vacuum, they jitter. These random fluctuations create tiny spikes of energy called virtual particles that constantly pop into existence and immediately annihilate each other. We can actually measure this seething activity. If you place two uncharged metal plates extremely close together in a vacuum, the space between them restricts the wavelengths of these virtual particles. The outside fields have more chaotic fluctuations, and that difference in energy actually creates a physical pressure, squeezing the plates together. This is known as the Casimir effect. Empty space physically pushes on metal. True nothingness cannot exist in our universe. The void is actually a restless, hyperactive ocean of potential. If the space around us is packed with active fields, what about the gravity holding us down? We feel it as a steady force pulling us toward the center of the Earth. Albert Einstein realized that mass does not actually pull anything. Instead, a massive object like a planet curves the geometry of space and time around it. When objects travel through this warped geometry, they simply follow the straightest possible path along a curved surface. This is an accelerometer. It measures proper acceleration, the physical force felt by an object. If you place one flat on a desk, the data readout shows it is accelerating upwards at 9.8 meters per second squared. In general relativity, if you were truly at rest, you would follow the natural curvature of spacetime and fall toward the center of the planet. To remain stationary relative to the surface, the atomic bonds of the Earth must exert a physical force on your feet, constantly pushing you away from that natural downward path. The only time you experience zero acceleration is when you are falling. When astronauts train in a diving aircraft, they aren't escaping gravity. The floor is simply falling away at the exact same rate they are, leaving them in a state of free fall where no physical force is pushing against them. Gravity is not a force dragging you downward. Standing in your kitchen, the surface beneath you is an engine of constant upward propulsion, resisting the geometry of the universe. That brings us to our final assumption, the idea that this whole system started when an infinitely dense, perfectly tiny point exploded to form the universe. In physics, a singularity represents a mathematical limit rather than a physical object. It marks the point where density becomes undefined, and our current equations lose their ability to predict the physical state of the cosmos. In the 1980s, physicist Alan Guth proposed a different origin story. Before the hot, dense state we call the Big Bang, the cosmos underwent a period of cosmic inflation. The universe was saturated with a powerful field energy that forced space to expand exponentially, moving faster than the speed of light. By stretching space so rapidly, inflation ironed out any early irregularities, creating the uniform, flat universe we observe today. During this expansion, tiny quantum fluctuations in the underlying fields were frozen in place, eventually serving as the seeds that would grow into galaxies. And the math suggests this expansion is highly contagious. A theory called eternal inflation indicates that once this rapid stretching starts, it never completely stops everywhere at once. It simply pauses in localized patches. Each of those calm patches results in a hot Big Bang and a subsequent universe, creating an expanding fractal of realities. The evidence suggests our cosmos is one isolated bubble within an eternal, self-generating cosmic foam. Facing an eternal, invisible network of fields and warped geometry, it is entirely understandable why early humans looked at the stars and saw a deity. God was classically defined as an omnipresent, invisible entity holding all things together. But philosophers point out that equating gravity or quantum fields with a creator is a category error. It confuses a physical mechanism with a metaphysical being. A conscious deity is personal. It judges, loves, and listens. The forces of nature do not. The vacuum fields will push two plates together, and space-time geometry will crush a star into a black hole with complete mathematical indifference. What we are left with is a reality where we are localized, temporary patterns of vibrating energy. We are navigating the warped geometry of a tiny pocket inside a cosmic expansion that has no apparent end. Stripping away these illusions doesn't rob existence of its majesty. Instead, it suggests that a universe governed by blind geometry and quantum fluctuations is capable of generating immense complexity through its own internal logic.